The derivative of x. Two ways to think about this. Some people, like I thought of it as like it's negative, and then I did the product rule, and I'm going to have to distribute the negative across. You can also think of it as like a negative x times a y, but just be careful with that negative. When I took the derivative of y, so I had the first times the derivative of the second, the derivative of y is 1, so then times dy dx, plus y times the derivative of x, which is 1. The derivative of y squared is 2y dy dx, and then 7 is a constant, so it goes to 0. This becomes a lot easier once we solve it for dy dx. dy dx would be the first derivative, so I do need to make sure I distribute that negative across correctly. And I'm going to solve this for dy dx. When you're solving for dy dx, the process is pretty much the same. You want to get anything without a dy dx onto one side of the equation, everything else on the other. And then with what's left over, you can factor out the dy dx and then divide by the factor that is remaining. So looking at this one, factoring out the dy dx, I have a negative x plus a 2y. So we end up with dy dx is equal to y minus 2x over this negative x plus 2y. Now, one thing you do want to be careful with, or not really careful with, but one thing just to know, depending on which side you got your dy dx's on, you could have a different answer than mine. So just realize this answer is the equivalent answer to saying 2x minus y over positive x minus 2y. So basically, if all the signs are changed, that would also be an equivalent answer. So we are being asked to find a tangent line. To find a tangent line, we know we have to have a point and we have to have a slope. The slope is going to come from the derivative. Since this was done implicitly, we are going to plug in the entire coordinate instead of just the x coordinate. So plugging in that slope, we're just going to have, I'm going to use the first version of it that I had. So I have y minus 2 times the x coordinate all over the negative of the x coordinate plus 2 times the y. So I end up with, that is negative 5. And my pen is possessed. Cool. Negative 5 over negative 4, which is just 5/4. So in writing that tangent line, we know it's y minus the y is equal to the slope times x minus the x. So my tangent line becomes y plus 1 is equal to 5/4 of x minus 2. Wouldn't need the visual, but I do have the visual on here so you can see that blue is the graph of that curve that we have, and then the red is that tangent line that we just found. Questions on that problem? All right, so the other things I want to look at, so we've looked at the horizontal and vertical tangent lines. I want to spend the last problem today talking about the second derivative. So when you're finding the second derivative implicitly, the process is still going to be the same. Like you have to find the first derivative first, and then you're going to find the derivative of that first derivative. There are going to be some things that are a little bit different. Often when we're finding the second derivative, we want it to be in terms of x and y. So let's just go ahead and start finding the derivative. I have x squared plus y squared is equal to 36. Taking my derivative, that becomes 2x plus 2y times dy dx is equal to 0. When you're finding the second derivative, one just kind of hint I will give you is to solve for dy dx. Because taking the derivative when dy dx is isolated is just going to be a whole lot easier for you to kind of deal with. So I'm going to go ahead and subtract the 2x from both sides and then divide by the 2y, since that's 2y times dy dx. The 2's cancel out, and we see that the first derivative is just negative x over y. So that's the first derivative, and then I can go ahead and find the second derivative. We know that the second derivative is just the derivative of the first one. So my second derivative, I see this as a fraction, so I'm going to have to use the quotient rule. So I have low d high less high d low, and here's where the implicit comes in. The derivative of the bottom is going to be the derivative of y. The derivative of y is 1, and then we have dy dx after it. So low d high less high d low. Draw our line, and down below the bottom squared will go. If you leave your answer like that, that is technically not answering the questions asked, because it asks you to find the second derivative in terms of x and y. This is the second derivative in terms of x, y, and dy dx. So the next thing you want to do is want to kind of take care of this dy dx. Well, what is dy dx? We know that dy dx is this negative x over y. So to answer the question and have it in the form that it wants us to have it in, the second derivative, I'm going to clean it up a little bit as I write it, but we have negative y plus x. What is dy dx? That's x over y, all over y squared. That final answer does answer the question that is being asked. It's not like simplified all the way, but that would answer the question if that's what you were asked to do. That is the second derivative in terms of x and y. Questions on that problem?
Why would you use dy dx if it's also in terms of y?
Why would you use?
Because don't you only do dy dx when you're in terms of x?
So don't mix up the phrase. So this is, we want our answer in terms of x and y. This is not us taking the derivative, if I go back up here, with respect to x. So there's a difference when I say take the derivative with respect to x or take the derivative with respect to y. This is just stating the way the question is worded. We want our answer just in terms of x and y. We know it's with respect to x because of how the denominator of this derivative notation is written. Any other questions on that one? All right, so often on the AP exam, a very common question is usually like a part A of a free response question dealing with implicit differentiation, is they won't word the question this way of find the second derivative in terms of x and y. Instead, what they would word it as is they would word it as show that the second derivative is negative 36 over y cubed. The AP exam, we're going to see this fairly often this year. When they use the word show in a problem, they're telling you the answer. They're like, hey, calculus student, the answer to this second derivative is negative 36 over y cubed. So you have to show your work very clearly of how you go from the very beginning to the end, because basically what will be graded is your work, since they are giving you the answer. The reasons why they do this, so often the free response questions will be a part A, B, C, and D. By giving you the second derivative, say if you messed up finding it on your own, you at least have the correct answer that you could use for the follow-up parts. This is the same problem we did before, so I'm just going to kind of copy and paste where we left off on. So we have gotten to the point right here where this is the second derivative that I have. And we need to somehow show that this second derivative is the same thing as saying negative 36 over y cubed. So how we need to do that, we need to just kind of start thinking about different ways that we can simplify this problem. So I would probably start off simplifying this one first by just getting rid of the extra denominator. So if I'm simplifying this one, I can say, okay, well, let me just multiply both sides by y over y, making sure I distribute across in that numerator. So then the second derivative becomes negative y times y is negative y squared. For that second term, the y cancels out, but we do have an x times an x, giving me minus x squared. And then all this is over y squared times y, which is y cubed. So we're getting close. We have the denominator is good to go. We can see the denominator is y cubed. Any ideas of how we can get that numerator to turn into a 36? We can take out a negative. So if I take out a negative, I see I have y squared plus x squared all over y cubed. Well, by taking out the negative, what do we know that y squared plus x squared is equal to? 36. 36. So from the original problem, and this often happens when you find a second derivative, in that the original function is sometimes hidden within that derivative, or not function, curve. We know that x squared plus y squared is 36, so this becomes negative 36 over y cubed. Showing your work and process clearly for this type of problem is important because, again, they're telling you the answer, so no one's going to be proud of you for saying the derivative is negative 36 over y cubed. What you need to be able to show is the steps of how you go from your second derivative into the one that you are expected to be able to find. Questions on that problem?
Wait, could you explain how you got 36 again? Because
the original equation they gave us was x squared plus y squared is 36. So I just did some substitution.
got you.
So it was... Any other questions? All right, so that's all I actually had to get done today. So I almost did them all yesterday, but that's all I needed to get done. So this is your assignment. Again, looking ahead, so we have homework 5 that was assigned. That was the PBA worksheet. Homework 6 is the bookwork. Again, you do not need to know how to do number 20 or 56 for this class. I'm also going to go ahead and assign homework 7, which was the more AP problems. There's 4 of them, 2 PBA problems, and then 2 implicit differentiation problems. Your test is on Friday of next week. Next week, we are just going to have work days. Like I might have a few problems, 1 or 2 to review, but I'm going to save those days mainly for you to work and get ready for your test. On your briefcase binder, of course, things we'll be working on next week. You have your quick reference. You have the unit summary, you have the AP review questions, the multiple choice ones, and then you have your quiz corrections. Remember, if you do all your homework and the quiz corrections, that's an automatic 5 points on your quiz. So like if you have a 98 and do quiz corrections, your quiz grade is going to become a 103. You have an 80 on the quiz, plus 5, it will become an 85. But that is reliant on you doing all the homework. So for the remainder of class today, like if you want to stay in the online meeting, you can. If you want to leave it and come back in as you have questions, that's also fine. But I just want you to use the rest of your day today before the long weekend to kind of continue working on homework 6 and 7. Again, I do want you to be able to enjoy your long weekend. So Wednesday and Thursdays are just going to be like work days for you to get everything completed. So that concludes what I have to get done. Again, if you are leaving the online meeting, I hope you have a good weekend. And if you're staying in it, then feel free to stay back and ask questions.